Hi, welcome to my video. In a system of linear equations, two variables, solving by elimination method. And this is part 6 of solving by elimination. Solve by the elimination method. What about solving a consistent dependent system by the elimination method? A consistent dependent system has two equations which have the same slopes and the same y-intercepts. So we have two equations, but we can't recognize that they're the same equation, because when you take the two equations and solve them for y equals mx plus b, you get the same slope and the same y-intercept, which means the two equations are representing the same line. So let's solve this system here. So let's take this equation, and notice we have to write it as ax plus by equals c. Ax plus by equals c, true. Ax plus by equals c, so they're all the same. So we have to eliminate, so we can take the lower numbers for the y. So we'll multiply this one by 5, and we'll multiply this one by 3. They're already plus minus. Remember, I could have did a 10 and a 6. I could have did a 5 here and a 3 here, but I'm eliminating y's because they're smaller numbers. So when we multiply, and again, this is equation 1, this is equation 2. Keep that in mind. 5 times this will give me 30x plus 15y equals 5 9s 45. When I multiply this equation by 3, I'll get a negative 30x, a negative 15y, and 3 times negative 15, negative 45. So I eliminated the y's, but when I draw a line under this, I'm going to add them up. The y's are gone, the x's are gone, so there's a 0 on that side. And 45, negative 45 adds up to 0. So notice the equation, this works out to be 0 equals 0. And again, 0 equals 0 has, if you think about it, it's the same slope, so it's the same line. So the solution set is one of the equations. So we have to take one of these two equations and write them down. So the solution set is this equation. And if we get really sophisticated, we write it down as the set of all x and y such that 6x plus 3y equals 9. And that's the official way, but I just wrote down the equation because all the points that satisfy this equation are also going to satisfy this equation because the two equations are the same. And to illustrate that, let's take the first equation, which is 6x plus 3y equals 9, and solve it for y equals mx plus b. So negative 6x plus 9. 6x moves over to become negative. Divide by 3. I get y equals negative 2x plus 3. I'm going to write down the second equation, which is negative 10x minus 5y equals negative 15. I'm going to solve this equation for y. Y equals mx plus b. 10 moves over, negative 10 becomes plus 10. 15 is already there, so it won't change sign. Divide by negative 5. Negative 5 divided gives me a 1. 10 divided by negative 5 is negative 2x. Negative divided by negative, positive 3. So notice these two equations turn out to be the same when you solve for y. Notice the two equations have the same slope of negative 2 and the same y-intercept of 3. So they're the same line. So when you solve this system, which represent two equations represented by one line, then you solve by elimination, you're going to get 0 equals 0. So anytime you get 0 equals 0, solving by elimination, you know that you have the same line and you have many solutions. So the equation one of the equations can be written down for the solution. Note, when the equations are added, you get 0 equals 0. So when you add these equations, you get 0 equals 0. This is true for all consistent dependent systems. 0 equals 0 when we solve by elimination. 0 equals 0. And let's continue. Solve by the elimination method. Practice. So we're going to practice. So practice means pause the video, work these out to see if you get the correct answer. And press playback. So this is number 1 equation. This is number 2 equation. So we have to line the equations up. So 2x minus 10y equals 4. So what we're doing elimination method. We got ax plus by equals c. Nice to write them like that. So it's not like it, so there it is. The 10 moves over to become negative. The 4 moves to the right to become positive. And the second equation, 4x minus 20y equals 8. The 8 moves over to become positive. Now I have these two new equations all lined up. So which one do you want to eliminate? Well, the smaller number is the 4 and the 2. So we can multiply this one. We need a plus and a minus, so we'll multiply this one by negative 2. And we'll leave this one alone and multiply it by 1. So here we go. Negative 2 times 2x is negative 4x. Negative 2 times negative 10 plus 20y. Negative 2 times 4 is negative 8. 1 times 4 is 4. That was not going to change. 1 times negative 20, negative 20y. 1 times 8 is 8. So I'm eliminating the x's, but really, now I draw a line. What happens? When you add, you get a 0. When you add these two, you get a 0. So 0 on the left. When you add these two, you get a 0. So we get 0 equals 0. So that means the solution is one of the equations. So write down one of the equations. Why? Because there's many, many points. These two equations are the same when you solve them for y. So if you solve this equation or if you solve this one for y, you'll get the same equation. That means there's many points on that line. That means there's many points that satisfy these two equations. So therefore, one of the equations will be the answer. And officially, if you want, the set of all x and y, such that 2x minus 4 equals 10y. And if you want, you could say where the x and y belong to, if you want to say real numbers, just more extension, because any numbers will be due here. You can have radicals, you can have anything, but we didn't deal with any radicals. Number 2. Now we got to line these up. This is equation 1. This is equation 2. So I'm going to move the 6x to the left and make it positive. The 9y is okay, and the 9 is okay. The x is okay. The y has to move over to become negative, and the negative 6. So we had to move the x to the left, make a plus. We had to move the y to the left to make it a minus. They're all lined up. So what do we multiply them by? Which one do you want to eliminate? So you can go with so notice they're plus and minus. So I could say 4 and 6. I could also say 2 times 6 is 12 and 3 times 4 is 12. I could go with a 2 and a 3. I can go with a 4 and a 6. If you switch these numbers, you'll automatically be always right. In other words, if you're eliminating this one, multiply that one by 6 and multiply that one by 9, you'll make them, 6 times 9 is 54, 9 times 6 is 54. So switching these numbers. But there's also smaller numbers, like 6 and 4 have a multiple of 12. So 6 and 4 divided into 12, so 2 times 6 and 3 times 4. But it's your choice. So 2 times this equation is 12x plus 18y equals 18. Multiplying all of these terms by 2. Now I'm multiplying all of these by 3. So 3 times negative 4, negative 12. 3 times negative 6, negative 18. 3 times negative 6 is negative 18. And I looked at eliminating the x's are gone. As it happens, the y's are gone. So the left side is a 0. And 18, negative 18 is a 0. So again, they're all gone. So the solution set is one of the two equations. Your choice. 9y equals negative 6x plus 9. And officially, mathematically, it's the set of all x and y. Why the set of all x and y? Because there's x and y in the equation, such that, write down the equation. There's the equation. So any point that satisfies this equation satisfies the system. And the set of all x and y, where x and y belongs to the real numbers R. That's the official answer. But some teachers will allow you just to write down one of the equations. Your choice. And that brings us to solving elimination when the system is consistent dependent. If you like my video, click the like button, click the subscribe button and the notification bell, because there are more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find out more information about me, my videos, and my content that's going to be on my YouTube channel, Math Fully Explained. Thank you for viewing my video. Bye-bye.